Hello, I'm Jem from Huawei Developers and welcome to Huawei Tutorial Series. Today, I'm going to show you the capabilities of the AR engine and how to use that AR engine body and face integration. The human body and face tracking capabilities also enable your device to understand people. By locating hand locations and recognizing specific gestures, AR engine can assist in placing a virtual object or applying special effect on a hand. With the depth sensing components, the hand skeleton tracking capability can track 21 hand skeleton points to implement precise interactive controls and special effective overlays. With regard to body tracking, the capability can track 23 body skeleton points to detect human posture in real time, providing a strong basis for motion sensing and fitness and health apps. AR Engine tracks real-time information related to human bodies, faces, and hand gestures to assist your apps in implementing natural interactions between users and virtual objects. Gesture recognition. AR Engine can identify multiple types of gestures, output the identified gesture types, and provide the screen coordinates of the palm detection box for both the left and right hands. Hand skeleton tracking. This feature identifies and tracks the position and orientation of 21 hand skeleton points to form hand skeleton models. It also distinguishes between the left and the right hands. Posture recognition. This feature identifies different human body postures. Currently, 6 posture types can be identified. Body tracking. This feature identifies and tracks 2D positions of 23 body skeleton points or 3D positions of 15 body skeleton points and supports the tracking of 1 or 2 people at a time. Human body mask. This feature recognizes and tracks the area where a person is located within the current image and provides for depth-related information. Facial expression tracking. This feature calculates the facial poses and the parameter values corresponding to expressions in real time, providing for meticulous control over facial expressions of virtual character. Face mesh. This feature calculates the pose and mesh model data of a face in real time. The mesh model data changes to account for facial movements. Health check. AR Engine detects facial health indicators and calculates key health information in real time to provide the health check function, including the heart rate, respiratory rate, facial health status, and heart rate waveform signals. Before you get started, you must register as a Huawei developer and complete identity verification on Huawei developers. Second step, we will establish all the development environment requirements. Then, we need to conclude all the necessary steps in the App Gallery console side. Configuring the AR Cloud service is optional. To use the 3D cloud recognition function, you need to configure the AR Cloud service. Enable the OAuth 2.0 app authentication service and upload the SHA-256 certificate fingerprint. For details, see API Console Operation Guide. On the AR Cloud Recognition Management platform, upload a 3D model, train and release an AI recognition model, and obtain the model name. For details, see AR Cloud Service. Afterwards, we will need to integrate the AR Engine SDK, followed by the necessary permissions. This section introduces how to use the AR Engine Java SDK to quickly develop your app and provides Java and Kotlin sample code for your reference. Since the AR Engine code is a complex project, only pseudocode for key steps is demonstrated here. The following figure shows the general process of using the AR Engine SDK. 1. Create and start AR session. 2. Call AR session update on each frame for update. 3. Return AR frame from AR session. 4. Get camera pose and tracking result from AR frame. 5. Get hit test. 6. Create an anchor using the hit point and add it to AR session. 7. Render camera preview and virtual objects. Repeat 2 to 7. In this section, you can check the AR availability. Check whether AR Engine has been installed on the current device. If yes, the app can run properly. If not, the app automatically redirects the user to the App Gallery to install AR Engine. The code is as follows. After you check AR availability, you can create your AR scene. AR Engine supports 5 scenes including motion tracking, AR world tracking config, face tracking, AR face tracking config, hand recognition, AR hand tracking config, human body tracking, AR body tracking config, and image recognition, AR image tracking config. The following code uses the motion tracking scene as an example. Create a motion tracking AR session by calling AR world tracking config. Select a specific config to initialize the AR session based on the application scenario. After a motion tracking AR session is created, use the config set method to set parameters for the current scene, such as setting the power consumption mode using the set power mode and focus mode using set focus mode. Configure the AR scene parameters and enable the AR scene. After the parameters are set, pass them to the motion tracking AR scene using AR session configure. Call AR session update in onDraw frame to get AR frame, and call AR session get all trackables AR plane class to obtain the AR plane captured by AR engine. The calculation results of AR engine can be obtained by frame. Obtain the data of a frame from AR session. Obtain the AR camera object from the AR frame object. The AR camera object can obtain the projection matrix of the camera to render the window. Obtain all trackable planes from AR session. After the plane is captured, click on the plane on the device screen to trigger the hit test, and add the hit result as an anchor, AR anchor, to the AR session for continuous tracking. Pass the click event to the AR frame object and generate the hit detection result. Create an anchor at the detected hit location to enable the AR engine to continuously track the location. Draw the required virtual object based on the anchor positions. You can see the results after running the project. Thank you for watching. For more detailed information, you can visit developer.huawei.com.